I think I got this bitch working the way that I wanted to. God damn it. I had to throw in a special case when there's an even numerator. Even more than what I already fucking had. Um, yeah, I don't know. Maybe I just rewrote it too goddamn many times. Like, it might have been working at one point and I just broke it. But, so up here now, come all the way to the top. There we go. So when it initially has an even numerator now, it splits it out like it used to. But now it knocks off 1 and then triples it so that you end up with some odd numerators in there so that it can actually, because it is the odd numerator rule that I have in here, which is the one that allows it to grow infinitely. So if you just have an even numerator and you split it into even parts, it dies. It doesn't go anywhere. So you need odd parts. So I just got that bitch working correctly. Who knows what was happening before? I'm probably wrong, but I've actually like manually checked a few of these, so I'm pretty sure it works now. Um, but there is another point. I don't think it's possible to encapsulate this with a generating function like you normally want to be able to with an infinite series, because you can see it as we get down here a little bit. There are multiple seed points where it is growing from, right? So here you can see this. Right before this 3 we're getting a 2, right before this 3 we're getting a 2, right before this 3 there's nothing, and then in the next iteration you get a 2, and then over here we get a 2 on this 3, and then we get a 2 on this 3. So the way that it's growing in multiple points. This is one of the things that I wanted to do that the previous version did not. The previous version that was possibly working, because it wasn't inserting in situ, it was appending to the end of the list. So you just ended up with like a pile of 1s and 3s at the end of the list instead of where they should be. They should be in these locations. So even when we go all the way out here, right, you end up with a string of 1s, a 3, a string of 1s, a 3, a string of 1s, right? And some of them will have a 2 in front of them because this iteration has not fully processed yet. As we get down to the very bottom, this last one, there's no more 2s, it's just 1s and 3s. The one right before it, there's a 2 just before that last 3. And that 2, so if we follow this line down, boom, it's right there. That's our line, right? So that 2 became these 2 1s. And then now we're down to just 1s and 3s. So we'll go through the next cycle, which will start pulling apart these 3s into 2s and 3s so that it can grow the next stage. But the fact that these seeds of growth occur throughout, they're peppered throughout the infinite series, means that I don't think you can model this with a standard generator function. And also look at like how this sequence goes: 4, 28, 11, 231, 32, 2016, 95, 17, 955, 284. Right? Like it's just all over the place. It's up and down like crazy. Right? Like this is a big ass number. Right? We're looking at like over a billion, I think, if I'm quickly reading that correctly. But over here it's like 22,000. Over here it's 11 million, and here it's like 8,000. Yeah, and over here we have just 46. 46 comes after nearly 10 billion. Two after nearly 10 billion, you get 46. And then way the hell out here we get, let's see, what's the smallest one I can find? The most ridiculous one I can find. I think this is actually a 20. Yeah, that comma comes right before it. This is actually a 20 right here after 294 billion. Right? This is not a normal sequence. This is not the kind of sequence that you can generate, I don't think, with a normal function. I could be wrong. There's definitely going to be some kind of pattern to it, but I don't know. It would be impressive, I think, if you could come up with a generator function for all possible versions of this, given any two inputs as your numerator and denominator, and these following these rules. That would be impressive. That would be pretty fucking impressive. I'm skeptical that it's possible, but maybe.